Okay, we're live, and yeah, we continue. Yeah, let me quickly find our tutorial on YouTube. We continue to learn Rust with Axum.
Cargo to ML, and we're going to add towers cookie. So again, most of
Okay, I already added cookies. Let me actually save this change.
cookies. And now if we scroll down to the second hello to Mike, we can see that he has the client cookies. So that is pretty cool. Okay, let's remove our second hello to Mike. We don't need it. And now that we have that, we are ready to implement our REST API. And for that, the first things we are going to implement is a model layer. So we're going to have a model module. We're going to jump into it. And so the architecture
So in main RC we have mode error, mode web, and now model.
architecture that I like is this one where you have the web event.
Okay, web, context, even model, and store.
Context and model and store. And today we're going to focus on the web layer, which is our REST, our handlers, middleware, and so on. The context, which we're going to have a quick introduction later, and the model, which is what we're going to implement right now as a mock model. So the implementation here is going to be a simplistic model layer and with a mock store layer embedded. You don't want to use it for production, but the goal is to have the model interface relatively close to where you want to land later, such as then you just have to change the store layer and the model layer implementation, but the rest doesn't really have to change too much. So first we're going to use our create error and result. Eventually you probably want to have a model error and model result. Pair here, we're going to use 30, and because it's going to be extremely simple and in-memory store, we're just going to use the standard arc and mutex. So in our first code section, we're going to have our ticket types. So that is the item that we're going to have the CRUD on. Like a ticket is like a to-do, like a task. And the first one is going to be the ticket that are going to be saved. And that is just going to have an ID, which is a U64, and the title, which is going to be a string. And then we're going to have...
Okay. So pub_struct ticket, which have pub ID U64 and pub title string. Yeah, there is so many different types of string in Rust. So far I'm not sure which one to use in each case, but yeah.
Have it clone because we need to store it, but we need to clone it such as we can send a copy back to the client. And then we're going to have our debug. and our serialize, because it has to be serialized to
Okay. Drive, clone, debug, serialize.
JSON when we want to send it to the client. Let's make some room. And now the second type that we're going to create is a struct for ticket for create. So that is the payload that is sent for the create API. And
Ticket for create. Okay.
And for now, the only thing that the user can create is a title, because obviously the ID is generated by the backend and not by the client. So on this one, we're going to derive it from deserialize, because the only thing we need is to deserialize from JSON to Rust. So now that we have these two types, and eventually you might want to have a ticket for update, which might have a lot of option properties. Such as it can be a partial update. But for now, we're just going to do the create, the list, and the delete, so that will be plenty enough. Now we can close this section. So one pattern that I like to follow is to have the model controller, and for now it's going to be extremely simple. It's going to be a model controller, and it's going to have the store embedded in it. And usually it will be more kind of a database connection or SQLX inside the model controller, but right now the store is going to be embedded in it, and it's going to be in memory. So it's going to be tickets store. It's going to be an arc, and we're going to put everything behind a mutex, and it's going to be a vector, so that will be our store, and that will be an option of ticket. But for our mock, we're going to use a vector ID as a sequential number, such as is going to be our.
Okay, this is something interesting. So okay, there is two option of mutex is from STD or from Tokyo, and let's have a look which one is used. Okay, balls from std. And of course I want to ask ChatGPT. What does this type mean? Maybe yeah, vector is clear. This mutex provides thread safety by ensuring that only one thread can access to the vector at a time. This is crucial in multi-threaded context to prevent data races. Okay, and finally arc. Atomic reference. Hey, hello, how you doing? I'm here learning Rust via Rust Axum course from Jeremy Chan. Now I'm just trying to follow what he's explained here, and dive deeper in topics like here what it's not super clear to me. So yeah, arc is atomic reference counting, wraps around the mutex and provide ownership. Yeah, I read about it in the Rust book, but it was a while ago and haven't really used it, so let's see. In summary, is a type that represents thread safe shared ownership to a vector of ticket structures. This type is common in Rust when you need to share data across multiple threads in safe manner. Okay. Hey Eldin, how is it going? Yeah, to be honest, the types like this looks a bit scary. Maybe after some time you get used to it, but
our ticket ID. And so we put it options such as
oh, I forgot to add option. So on vector, each ticket is the option. Okay.
such as when we're going to delete, we're just going to swap the option by none. So obviously that doesn't work in production because that will be a vector in memory that will grow infinitely. But for our mock store, it's very simple and it's behind the interface anyway. So now we're going to derive it. We derive it from clone, so that is important because that will be an application state. And it's important to note here that the clone doesn't clone the vector, obviously, it just clones the arc. And then we have a mutex that protects our vector, that makes the access of our vector exclusive. Now we are ready to implement our constructor, and it's just going to be a simple async new function that will return a result of self. And in the return of self, we just need to have a ticket store and the arc and the default. Now,
So self, yeah. Self is correct, and okay, self. Yeah, it looks okay.
Now, because we use the arc default here, we could also derive directly on the model controller, such as we wouldn't have to implement a constructor. But in fact, what you want is to control the signature of the constructor early on, such as then after you can swap the implementation with a real use case. So by making it async and returning a result, we are now sure that we can cover all of the cases and not paint ourselves into a corner. And now we can create our CRUD implementation. And one best practice that I like to have is to have different blocks of implementation per type of methods. But obviously you can put everything in the same block. This is just a personal preference. So the first CRUD method that we are going to implement is going to be our create, which is going to be an async create ticket. We'll take a reference of self and then our ticket for create, and it will return a result of ticket. So the ticket that has been created. We're going to get the store.
How goes the Rust learning? Yeah, it's fine. Like, I'm not like do a lot of learning, just to follow typing. It's kind of like muscle memory of Rust constructs, because I read book already, So the concept is familiar for me, but I'm kind of not sure how to use it, so this nice exercise to do, just follow some real world example and to see how the things is used. So far I liked. So ticket. Result ticket. Rust has become by default. If I'm starting a personal project and don't have reason to use something else for it. It depends, I think, like what kind of project and what is your goals. Like if your goal to have fun and use Rust, it's for sure, but I don't know. For example, for mobile project, I don't think I pick Rust. There is actually a fun, interesting project. It's like React Native, but with Rust. My stars. Yeah, this is experimental Rust architecture for reactive UI. So yeah, at some point it will, if it will continue to grow, maybe one day it could be picked. Yeah, that's what I mean. This, like, no, it's a picture I set myself. It's same I have. I don't know, let me check if you can see. If yeah, I set it on my desktop as well. I have another example, like yeah. So this is Python script which generate invoices for me. So yeah, to get payment I need generate invoice each month, and it already has good integration, like with Google Service. I do it from the Google Doc template, and again I feel like it's no reason to do it in Rust, except if you really want to do it in Rust. But it's much faster and easier, and it's work like it is. So, like, there is always tools, better tools for each case. Yeah, this is why it's a bit hard to start doing something in Rust for me. I'm always thinking like, okay, I can do this project better in something else. But on the other hand, I don't know. I'm just curious about Rust, and it's can like throw it away. It so I just do it and have fun. But the thing I choose Python, I don't even like. I didn't know Python at the time I write it is because it's has great integration with Google services like Google Doc. It taken a template from Google Doc, fill some placeholders, and then it generates PDF. It sends through Gmail, and it also do the record in Google Sheet. And I don't think there is all these libraries in Rust. Maybe I'm wrong, but in Python it's just so easy to do. Even because I never was fan of Python, but Python just everywhere. It's like another side of JavaScript. Oh, that's cool. That's actually interesting. Maybe I should take a look and even rewrite it for fun. Rust, great. Okay, I think the main thing here is like, at least from what I see, it's not maintained by Google. Just some people did it. And it's basically, usually it means at any minute it will be deprecated. and not maintain it anymore. Yeah, you see quick start. There is JavaScript, Go, Google Apps, Java, Node, and Python. There is no Rust here. But maybe in future I see how big company like Microsoft, Google, etc., Meta started using Rust more and more. So I believe it will change.
As a mutable from our ticket store, we're going to lock and we're going to unwrap. So that is for the mutex. And now the ID, and that is where it's a little bit hacky, but it kind of work, will be the store and the length, which is basically the index plus one. And it works because again, Rust guarantees that we have exclusive access to
I don't know how it works inside the company, but generally I saw like Google have some course on Rust for Android. Google Rust Android. So they also use, maybe in some places, Go makes sense to use over Rust. I'm not really know what anything about Go except from the Primogen streamer who always said it's easier to build something like to build server in Go. It would be preferred choice, even if he like Rust more, but Go just better thing there. But still, yeah, I think such a big companies, there are no like this monolith decision we will use Go or Rust. It depends on each team and their needs, and at least on the system level, like low level Android development, system development, Rust might be a better choice than Go for sure.
to the store array, read all.
Maybe, I don't know. Maybe they pushing it, or probably there is some internal vibe about Go, so they more familiar with Go and they all like happy about it. There is like different feeling internally and externally. Like people outside the Google always feel like, okay, it's something developed by Google, they can just throw it away at some point. like they do sometimes with things they develop. And people scary about it, like one, for example, Flutter, one of the comment about Flutter is okay, it's developed by Google, they can just stop maintaining it, we don't want to use it. But I think one of advantages of Go is it's simple. At least I hear people say it. And this is opposite to Rust. Rust is like complicated to learn. Okay, yeah, that's interesting. Yeah. Yeah, I just heard that Go is easiest to jump. Maybe like Python, as I mentioned this invoice script I wrote. I didn't learn Python, I just use it. Just check documentation and write things that works for me. Maybe it's something similar to Go. And I don't think it's possible with Rust. With Rust, you need... Maybe it's just my feeling, but... Yeah, I don't... I kind of don't like Python. Each time I doing something in it, it's a weird feeling for me. But the Python is super huge adaptation, like it has so many libraries and you can quickly do something, and that works in Python. Even I don't like it, I'm ready to use it in cases. It's okay. Yeah. Okay, so let me write a bit of Rust. So we do mutable store. So ticket store lock. I think log is mean no one else can use it, like other threads can't use it while it's locked. Oh, Perl. For me it sounds like something from the past, but I don't know. Is a Perl still a thing? I think how this company called? Booking, yeah, booking.com used a lot of Perl. I met I met booking developer in the Amsterdam and say he mentioned he doing a lot of Perl. Is is payment good for legacy Perl? Okay. Yeah, if it's not like hard to pick up, it makes sense. So, okay, this is interesting. It says it blocked the thread, so it's kind of stop the thread and wait until the mutex is available. Then it executed. Yeah, this is interesting.
All right, with the mutex. Now we can do a ticket, the ID, and the title will be our ticket for create title.
id star len as thing that make legacy Perl hard is that Perl makes it extremely easy to write. Oh, incomprehensible code. Okay. Oh. That's probably why it's not super popular anymore. Okay, I see. PHP wipe here. Okay, so many special characters. But it's interesting concept, like different data structure you mark with different sign. Never saw it before. And it's dynamically typed, right? As I can see. Okay, yeah, looks like not super hard to pick up, but as you said, it might be confusing. Okay, regex, I got it. So yeah, maybe there is cases. Probably good choice. But yeah, nowadays probably outdated.
And eventually here you can check if it's empty and then return a result if the title is empty or something like that. And now we're going to push it into the store. We don't forget to push it as an option, because when we are going to delete it, we're just going to take it out and leave a none over there. We're going to do a ticket clone, and then the original one, we're going to return it as a OK ticket. And that's it. We have our create.
So person hash is a hash table. Add hash is array where the even numbered elements are the keys and the odd number elements are the values. Oh my gosh. Okay. Yeah, sounds a bit weird, to be honest.
Great. Now, if we look at our list tickets, it's going to be relatively similar. So it's going to return a vector of ticket. We're going to get our store. We don't need mute anymore, so we can remove it. In this case, it doesn't really matter because the lock is exclusive anyway, but it's always good to have the intent correct. And then we're going to have our tickets, which is going to be our store. We're going to iter, and then we're going to do a filter map, and we're going to clone our tickets, which is going to clone the options. And because this filter map is going to exclude everything which is known. So everything that has been deleted won't be returned. And now we're going to collect. And now we're going to implement the delete. And eventually you want to implement also the get.
Okay, list of tickets. So list tickets. Result vector of ticket store self ticket store lock and wrap. So Filter, no, iter. We need iterator here. Then filter. Clone. Filter, okay, not filter, but filter map.
And now we're going to implement the delete. And eventually you want to implement also the get and the update. But for this tutorial, that will be enough. So we're going to do the self, and then the ID is 64. And then it will return a result of the ticket that has been deleted. So it will return an error if the ticket wasn't found, obviously. So we're going to get our mute store. So in this case, we need to have it mutable, obviously. We're going to get the ticket that has been deleted, which is going to be our store, get mute with the ID. And now we're going to do and then, so if it's found, which is going to be the option, we're going to take the value out. And so that will return an option of ticket if it was found. And so now what we want is to return an error if it wasn't found. So if we bring back our error.rs, in our error enum, we're going to add a section for our model errors. And eventually those, you will probably want to refactor them into the model layer, obviously. But right now we're going to put them there. And it's going to be ticket delete, fair ID not found. And we're going to have that as
So ticket delete ID not found, like this. We've been in model. I want to create a sync function delete ticket, or yeah, self ID here 64. What will be result?
a struct variant, such as we can name the property ID. So now
Oh, we had
that
some.
we have that,
Yeah, we need it mutable. Store self. So looking for a ticket. Get and then okay, I think this is why my LSP broken.
That we're going to return a ticket. We're going to make it a result with OKR, and if it's none, we're going to return our new error, which is ticket delete.
Okay, ticket ok or okay.
Failed ID not found, and the idea is that
Yeah, I wanted to look about get mat, what we're doing here. So the store is our mutex squared vector. So it return mutable reference to the ticket with ID, I guess. We put the ID Yeah, store is the muted protected vector. By the way, store name is confusing me. But yeah. Obtain a mutable reference to element at the position specified by ID. Oh. So we don't really look into ticket ID. We look in the vector position. In this case it makes sense, but on the logic level it feels a bit wrong. I don't know. It's kind of like index in vector and real ID. Maybe for the tutorial purpose it's fine, but I don't think it's a good idea to do it in the real life. So and then it's on the option time. Yeah, and then is method of the option, which allow function to be called on the value. If it's some, if it's none, returns a none result calling the function. In this case, function take is closure that takes the mutable reference t to the option ticket and call the take method on it. Take replace the option ticket at this position with none and return the original option ticket. This is interesting method. Yeah, now I think it's clear. Yeah, ChatGPT is so nice in this. Like when you dive in the code base, you're not familiar a lot, like with code constructs, functions, etc. And just in explanation of each call make you so much better in the understanding of what's going on here.
that were given to us. And that is the beginning of our mock model layer. So now we are ready to go to our web layer, and we're going to add a submodule, which is going to be our routes tickets. We're going to create the module, and we're going to go to the file. Now we're going to...
Okay, I think I will not start the next section. I will back to it next, and yeah, I'm going to my main job. So thank you all to be with me. We'll be happy to chat with you next time.